Okay, let's look at how we can get a CSV file, which stands for comma separated value file, into pandas. Now, the file that we're using is called meatprices.csv. If we go into our data folder, you can see it's right here under the data folder. It's called meatprices.csv. If we open this up, we'll actually see that it's a bunch of data here, and we can scroll to the right and see the whole bunch of meat prices going from December 2012 all the way to April 2019. And these are prices in Ulaanbaatar, and this data was collected from the National Statistical Office, so this data is real data. The way that you actually want to import a CSV file, and again, a CSV file actually is just basically a text file that is made up of, that's separated by commas, and that commas tells you where the columns are. And then every row or sort of line in that CSV file is a new row in the table. So when you actually see something like this, you can see what it looks like. And by default in JupyterLab, you can actually use a different delimiter, and you can actually change this. So I'll just put like semicolon, for example. And you can actually see what a typical CSV file looks like as a text file. So it's kind of maybe a bit hard to read, but this is basically what it looks like. But when you delimit it correctly, use the correct delimiter, it looks like a nicely formatted table. Okay, so you'll use, in order to get a CSV file in, you'll use pd.readcsv. And then the first thing you should put in is the path to the file that you want to import. This particular file is inside the data folder, so we'll use data/meatprices.csv. And for now, I'll actually delete this just so you can I'll explain what it does in a minute. It'll make more sense if I don't show you what it does first. Okay, so we're actually going to import our CSV file, and then we're going to save it to something called meat. We'll look at the head of the meat data frame, and we'll just get the first 5 rows. And we can see here we have the goods and services, so we just have like the meat type, the location, which is Ulaanbaatar, and then all the different prices. You'll see here, though, we have commas. If I use D types, you'll see that they're all objects. And the reason why they're all objects is because there's this comma here. Pandas doesn't understand what that comma means. It thinks that you might actually need to know what that comma is, and maybe that's important. So, but typically we don't actually care about this comma. This just tells you that it's a thousands, right? So there's this actual argument here that is thousands, and you can actually tell it the thousands delimiter here, which is a comma, and that will actually tell you what you can use for the delimiter. So let me pull up the documentation here, which is quite significant. So if you look at your contextual help, which again you can get with Control-I on your keyboard while you're in command mode on the JupyterLab, you'll see that this is all of the different arguments for the read CSV file, or method main. It's very extensive. There's a lot that you can do here. And here's this thousands right here. Now, going over all of these, typically I'm not going to go over all of them because you'll just forget it. But it makes sense, though, that as we go, we'll actually see these over time and with many different examples throughout this course. And so you'll learn actually several of these throughout the course. So, but for now, what you need to know is actually that the thousands separator is what we're going to use. And then when we do that, now you can see that there are no more commas in our numbers. And when we actually look at the D types, it's now an N64. So this is actually, this is what we want, right? Now we have our data imported. So that's pretty cool. But the problem is that we don't actually have the data in the correct format. Right now, this is what we would call short form or maybe statistical table form of data. This is really, really common. It's typically what you get from the government or even like research agencies and things like that. Typically, though, as a data scientist, we don't want it like this. We can do analysis of the data in this format, but it's a little bit more difficult. So what we're going to do is convert it into something called like a long form or like a database style of format, so that way we can actually analyze it easier. So let's take a look at how we do that. There's this thing called melt, so pd.melt, that will actually convert the data from a short form to a long form. So it'll kind of make it like this to like this. And it's not transposing it. It's not actually rotating it. It's actually going to melt some of the columns down, and then some of those other columns will just get copied. So you'll see how this works in just a minute. So let me, before I actually run all this, this is the completed code that you have, but I'll kind of take a step back so we can kind of see what it does. If you run just pd.melt by itself on meat, it'll actually give you this, which it doesn't look right. So it's actually making it like long form, but it's guessing and it's not doing a very good job. If we put our contextual help over here, we can see the arguments. So we can see the first argument is data frame, which is what we passed. The second argument is what's called an ID var. And here we can see that ID vars are our goods and services and our AMIG. Our goods and services and our AMIG are basically going to be the things that we want, and then the value that we want that are labels. The value is going to be the price itself, right? And then also, so we can see here that we have another one called month and price. I'll actually remove these just for now, just so you can see what it looks like. So if I do that and I say my ID vars are goods and services and AMIG, what it will do is it'll give me our IDs here, our ID variables. Then we have the actual variable, which is our month, and then we have our value, which is our prices. Now, by default, it will call this variable and value because you can see over here we have value vars, var name, value name, and then there's column level and other things that we don't need. But what we can do is we can actually rename the variable by saying var name is month because that's what it is, and value name is price because that's what it is. And then when we run that code, we can see that it's actually, now we have goods and services, which is our meat type, AMIG, which is our location. They're all Ulaanbaatar, so this is basically not useful, but we can drop that later. It's not really important for now. We have our month, and you can see that there's a lot of duplicated months because, for example, we have 5 different types of meat. So that means that every meat type has a price for every month. And then, of course, you have the actual price, Ugrix. Then what we can do is once we actually melt that, we're going to save it back again to the same data frame. We're going to kind of overwrite it because we don't need that old poorly formatted data anymore. And then we have our nice data frame. It's important to remember that, even though I overwrote the data frame before, I'm not actually changing the file. This raw file should never change. Whatever you get from your source, you'll never actually change that because you may want to go back. So we're only doing things right now, we're actually doing it in the memory of our computer, and then we're going to sort of output something from that. But the actual data file won't change. Okay. We're going to convert the month to a date time. And the way that that happens is, again, you can see that it's just basically text right now. So if we convert it, it will look like this. We don't actually need to convert it, but if we don't, it will end up looking like this on our x-axis, which doesn't look great. These are all the dates. So if we do convert it, then now when we plot it, not only will it plot much faster, but it will be much prettier. And you can actually see now that we have a nice little plot of meat prices. And this is actually beef without bones. This is the price of beef without bones. And then you can see this here. Okay, so in the last video I showed you how to make a quick plot, but I didn't go into too much detail. Let me break it down a little bit more about how to do this. The first thing you should do when you want to make a basic plot is think about x and y. Plots tend to be two-dimensional, which means you're going to have an x and you're going to have a y axis. Typically, it's a good idea to put your independent variable on your x-axis. Your independent variable, if you don't remember from high school or college, is the thing that does not change, and then the dependent variable is the thing that does change. The dependent variable should go on the y-axis, and the independent variable should go on the x-axis. Time is not changeable. It changes by itself, but we can't change it. So time should always be on the x-axis, unless you're making a really artistic point for some reason. So what we want to do, and remember I told you last video, and when you're making a plot, you want to think about the x and the y-axis. The x-axis is time, the y-axis is meat prices. So if you want to actually get meat prices, the time, the date, we can actually just call this. But the problem with this is that we actually have a bunch of duplicated dates. we're generally only going to make one plot for one meat price at a time. Later we can look at more advanced ways to do it, but for now we're only going to be making one plot at a time. The way to do this is to say, give me the data frame where goods and services is equal to beef without bones per kilo. And what that will do is it will give you like a true and false. Whoops. Oh, I'm actually doing this a bit differently. Here we go. So actually, oops. There we go. Okay, that makes sense. Okay, so if I say, give me the data frame where meat, goods, and services is equal to beef without bones, then that will return the whole data frame of only beef without bones, and then like the other values that correspond to that. Then what I can do from there is get only the month. So you can see that. Now this is doing the same thing. I could also just change this to price. That. Okay. Now the difference is, actually, if you look at the difference between this code and this code, is that here this price is up here, and over here it's actually on the end. It doesn't actually matter. They do the same thing, just whatever you prefer. You can stick it on the front or the back. But I wanted to break down what that code meant. Now what we can do is if we do months, we actually get only the months for that particular type of meat. And if we do price, we get only the price for that particular kind of meat. There you go. So that's what exactly I'm doing here on the plotting code. This first piece, which you can see here, whoops, I went too far. That's highlighted here. You can see that it's actually the x-axis, and then over here, which is the month, and then over here, you see this basically is the same thing. I just changed it to price. That's the y-axis. This is kind of long code here. What you can do if you'd like is after the comma here, you can just hit the enter key, and then now it's actually on multiple lines, and so you just have to remember that this is a comma. So this is the next thing, which is the y-axis. So you'll actually use plt.plot, which is the code and matplotlib are the method to actually create a plot. So you can see that x-axis is month, y-axis is price. When you run that, now you get a nice plot of beef prices without bones over time. And of course, it's quite interesting because now you can actually look at it, and you can see that way back in 2011, it was below 5,000 torgs per kilo, and at the end of 2019, it was almost 12,000, and actually went above that this year in 2020. But you can see over time how it's changing. This is quite interesting, and I think it's important to remember that matplotlib is what's called a scientific plotting library. That means that the scale you see here, like the dots in relation to the other dots, are actually sort of accurate. So you can actually say that, if I measure the distance from here to here, that actually tells me something about the data in relation to this y-axis. If you go to like the National Statistical Office website and look at their graphs that are actually on their website, those are not actually what I would call to scale. They don't actually, they're not showing the scale reference and the sizes correctly because they're just using a web JavaScript plotting library, and it's not a scientific library, which really says that you can't really look at those graphs and really understand what's going on. It'll look much more correct if you're using matplotlib. Okay, so that's how you import a CSV file. We did some basic cleaning where we actually melted it, and then we made a plot. For this week, your main goal is to actually just understanding how to import the data. This other stuff is just extra, and we're going to do this more in future weeks, but I'm just want to introduce it to you so that you actually kind of understand what you'll be doing, and it also hopefully makes it more interesting. In the next video, we'll look at how we can actually import Excel files and then do a similar analysis on them.